Yeah, before we get into the transformation, we also are going to have a complete clarification on forward fill and a backward fill. Let us have a data set. In this data set, Sarah's age is not available, and David's salary is not available, and Michael's salary is not available. Simple thing. In the forward fill, Sarah's age will be replaced by John's age because John is preceding Sarah. In the backward fill, Sarah's age field is going to be replaced with the David's field. The David's field is going to substitute in Sarah's field. So how are we going to do it? How exactly we're going to do it in a Python? We'll see. Okay. In the forward fill, you can see Sarah's age is taken from John's age. In the backward fill, same, Sarah's age will be taken from David. Okay. You can see Sarah's age is being taken from David's age. Now, how exactly we are going to do it in Python? Similarly, similar to the previous slide, we are going to use data frame.fillNA. Here, we are going to fill not available with the method. What is the method? Method is equal to ffill. Ffill should be in single quotations. Okay. So, what is ffill? Ffill stands for forward fill. Similarly, same thing, it is bfill. If you ever want to use the backward fill, you're going to say df data frame.fill not available values with the method of backward fill, and in place should be equal to true. Okay. So in backward fill, we are going to take the next field's value to substitute the current field's not available value. This is how forward and backward filling is going to work. Now let us jump into the transformation, data transformations. Now let us get into data transformation. What is transformation? After pre-processing the data, data will be available to feed into our model, to build our machine learning model. Now the thing is, we should be able to transform the data. What exactly is this transformation? In the simplest words, the data is available. For example, look at this agent salary. Agent salary actually distributed over a wide range. Age will be distributed from 15 to 90. Salary will be distributed from 10,000 to any long range domain. Now the data is distributed. When you want to take a graph, these data points are distributed over a long range. At this point, it is highly difficult for the machine learning model to perform better by reading the data that we are giving. So what we need to do is, we need to collect the data. That data that is collected should be transformed to a standardized format. How are you going to standardize data? What exactly are the techniques to standardize the data? Let us understand. Taking the same example of the previous data set, let me explain to you. Sample data set, we have 1, 2, 3, 4, 5, we have 5 people's data in which John, Sarah, David, Emily with their respective ages, salaries and the departments have been present. Now let us understand what exactly is the first method to standardize. The first method to standardize is feature scaling. What is feature scaling? In feature scaling, we are going to transform these values of age or salary, which are actually distributed over a wide range, into a simple standardized format. What is it? This will be having a mean of 0 and a standard deviation of 1. We're going to apply a z-score normalization. Something called a z-score normalization will be applied to these two fields. Right after z-score normalization is applied, then what's going to happen? All these values will be replaced with all the values will be normalized with a mean of 0 and a standard deviation of 1. One formula will be applied. Right after applying the formula, all these values will be replaced with every value will be having a mean of 0 and a standard deviation of 1. What is standard deviation? Standard deviation meaning from the mean, how distributed the values are, how average values are getting distributed. If the mean is equal to 0 and the standard deviation is 1, most of the values in the data set actually are only plus or minus 1 different from 0. Okay, standard deviation of 1. So let us understand how it's gonna happen. Yeah. So here We're going to use standard scalar. Scalar is equal to, we just have taken scalar is equal to standard scalar. This standard scalar function will be taken to a variable standard scalar, and then we're going to take data frame agent salary. This agent salary fields will be scalar fit transformation. What is fit transform? This fit transform is going to transform this these two columns into a mean of 0 and standard deviation of 1. Okay, in the data frame what we are taking? Age and salary. Now after transformation, you just can see John, Sarah, David's, Emily's, or whatever the rows that we have. These age and salary columns will be replaced with a mean of 0 and standard deviation of 1. You just can see all the values are having a mean of 0. And the second one is standard deviation of all the values will be just equal to 1. These are not beyond 1 in terms of the standard deviation. Okay, I hope you got it. Okay, so here age and salary columns have been standardized. The next thing is min-max scaling. What is min-max scaling? This is most often used. In min-max scaling, all the values will be distributed over a simple range. There, age has actually been ranged from 15 to 90, right? In the min-max scaling, generally we are going to normalize all the values in between just 0 to 1, most of the times. You also can use your values. If you want to scale from 0 to 10, you are welcome. But generally what we do is, in min-max scaling, we are going to take the values of 0 and 1. Okay. So in scalar, now what we are applying? Min-max scalar. Earlier what we applied? If you look at this. Okay. The standard scalar, we are going to understand this when we deal with pandas more. And in this standard scalar, in Python, standard scalar, this standard scalar is going to standardize by using a standard deviation of 0 and a standard deviation of 1 and a mean of 0. And in min-max scaling, we are going to take a variable scalar to which we are going to pass min-max scaling. Okay, this min-max scalar is being passed to one variable called scalar, and now my data frame with respect to age and salary will be normalized with a min-max scaling. Okay, in min-max scaling, the range will be 0 to 1. Okay, so here you just can see age and salary can be replaced with, are actually replaced with a 0 and 1. You can see all the values are just in between 0 and 1. In the next session, we are going to discuss about the next standardization.